Welcome everyone in lecture number 27 of statistics. The topic of discussion is sampling distribution of sample means. In my last lecture, which was lecture number 26, I have told you about the sampling distribution of statistics. In particular, sampling distribution of sample means, which is defined as the collection of sample means corresponding to each sample drawn from the population. So in that lecture, we have seen that if we draw the samples from normal population, no matter what the sample size is, the sampling distribution of sample means is always normal in shape. Today, we will discuss the effect of sample size on the standard deviation of the distribution. So let's begin with drawing the samples from the normal population with a mean of 100 and standard deviation of 25. Suppose this is a normal population whose mean is 100 and standard deviation is 25. Suppose we draw samples from the population and sample size is suppose n is equal to 5. And if we calculate sample means from these samples, which has the sample size is equal to 5, these means are suppose 95, 106, 101, and so on. You can see some values of sample mean are smaller than 100 and some values are greater than 100. कुछ values 100 से छोटी हैं, कुछ values 100 से बड़ी हैं. It means that there is as much chance for the sample mean to be above the population mean as there is for it to be below the population mean. Means जितने chances sample mean के population mean से कम होने के हैं, उतने ही chances sample mean के population mean से ज़्यादा होने के भी हैं. Right? So, because in this sample size of 5, you are averaging 5 items. Right? So, very large value among those 5 values will get averaged down and very small value will get averaged up, because we know that average is nothing but the representative of all the numbers whose average is calculated. तो ये जो 95 है, ये इन सारे नंबर्स को रिप्रेजेंट कर रहा है जो फर्स्ट सैंपल में हैं. तो फर्स्ट सैंपल में जितने भी नंबर्स हैं, उनमें जो सबसे बड़ा नंबर होगा, that will be averaged down and the smallest number will be averaged up. So average will make equality among all the numbers. Similarly here, all the numbers are represented by 106. So what is the meaning of these numbers? Means when you draw the sampling distribution of sample means, जब हम sampling distribution of sample means draw करेंगे, means x axis पे हमने sample means लिए हैं यहाँ पर और y axis पर उनकी frequency या probability. तो जब आप शेप देखेंगे, इसकी शेप तो नॉर्मल ही मिलेगी हमें क्योंकि पॉपुलेशन नॉर्मल है, लेकिन इसकी विड्थ कम हो जाएगी, स्प्रेडनेस, स्टैंडर्ड डेविएशन विल गेट reduced. It may be 20 or 15, right? It may get lesser than 25, but mean will remains 100. means mean of sampling distribution of sample mean is equal to population mean. तो जो यहाँ पर वेरिएशन था पॉपुलेशन के मेंबर्स में, एवरेज लेने से वो वेरिएशन रिड्यूस हो गया. If you increase the sample size, suppose from n is equal to 5 to n is equal to 10, then this would not change the standard deviation of the original population, but it will reduce the standard deviation of the sampling distribution of the sample means whose sample size is equal to 10. यहाँ पर sample size 5 है, यहाँ पर सपोज सैंपल साइज जब आपने 10 लिया, मतलब आप 10 वैल्यूज का एवरेज निकाल रहे हैं एक सैंपल में. तो मान लीजिए पहली वैल्यू आई 90, सेकंड सैंपल से जो एवरेज कैलकुलेट होके आया दैट मे बी 92, थर्ड सैंपल से जो एवरेज आया दैट मे बी 87 and so on. So you can see the spreadness, the deviation of the values or the distance between the values is keep on reducing due to increasing the sample size, because here the variation among the population members is greater, but when you take the average of the group, that average represents all the values. So the smaller values in that group, the smaller values in that group will get averaged up and the largest value in that group will average down. तो ये एक ग्रुप है, ये एक ग्रुप है जिसमें 10 मेंबर हैं. इसी तरह से हमारे पास ये सैंपल्स हैं. तो इन सैंपल्स के अंदर जो एलिमेंट्स हैं, जो नंबर्स हैं, दे आर रिप्रेजेंटेड बाय वन सिंगल नंबर. So the variation among these two numbers or among all the numbers will be lesser as compared to the variation among these numbers. In other words, when you draw the sampling distribution, the standard deviation of such distribution will get reduced again, but mean will remains same and sigma x bar may be 10. So you can see the effect of increasing the sample size would reduce the standard deviation of the sampling distribution, but the shape of the distribution will remains normal when the sampling is done from the normal population. So we can state a theorem that if mu and sigma square are mean and variance of a population and random samples with replacement हम तब करते हैं जब population finite होती है, when the population is when population is finite. Finite का मतलब size is very very small. तो हम सैम्पलिंग विद रिप्लेसमेंट करते हैं, मीन्स सैंपल में हमारे मेंबर्स रिपीट हो सकते हैं, और विदाउट रिप्लेसमेंट when n is infinite. Infinite का मतलब very large. If mu and sigma square are mean and variance of population and random samples with replacement or without replacement of size n are taken, then sampling distribution of sample mean has mean equal to mu and variance equal to sigma square upon n. You can see the variances get reduced. So original variance was sigma square, but sampling distribution of sample means has variance sigma square upon n. So we can prove this. Let sample mean x bar be x1 plus x2 plus xn divided by n, where n is the sample size. तो आप सैंपल मीन ऐसे ही निकालेंगे. अब हमें इन सैंपल मीन्स का मीन देखना है, मतलब एक्स बार की एक्सपेक्टेड वैल्यू, मीन्स एक्सपेक्टेड वैल्यू ऑफ x1 plus xn whole divided by n. So this is equal to 1 upon n by the property of expectation, expected value of x1, expected value of x2, expected value of xn. All these x1, x2, xn are coming from the population whose mean is mu. So their expected value is mu. So we can write here, this implies expected value of x bar mu plus mu plus mu, because each x1, x2, xn are from the population with mean mu. So their expected value is equal to mu. So this mu is getting added n times. So this is equal to mu. Hence, it's proof that the sampling distribution of sample means has mean is equal to पॉपुलेशन मीन। मतलब सैंपल मीन्स का मीन आप दोबारा निकालेंगे तो वो पॉपुलेशन मीन के बराबर आएगा। इसी तरह से वेरिएंस ऑफ एक्स बार हम कैलकुलेट कर सकते हैं। अगेन वी अप्लाई द वेरिएंस ऑन द फॉर्मूला ऑफ एक्स बार दैट वी हैव कैलकुलेटेड. Sorry, this is variance applied over x1 plus x2 plus xn whole divided by n. By the property of variance, this will become n square. Variance of x1, variance of x2 plus variance of xn, because covariance term is 0 because all these elements are independent. Variance of x1 is sigma square because this x1 is coming from the population whose variance is sigma square, so the variable has also variance is equal to sigma square, sigma square, sigma square. This sigma square is getting added n times, so this is sigma square divided by n, or you can say that sigma x bar is equal to sigma by root n. This is sigma square. And this here the notation is mu x bar. So let's do one example. In a normal distribution with mean (375) and standard deviation 48, how large a sample must be taken so that probability will be at least 0.95, that the sample mean falls between 370 and 380. क्वेश्चन का मतलब क्या है समझ लीजिए एक बार। नॉर्मल पॉपुलेशन में जिसका मीन 375 है और स्टैंडर्ड डेविएशन 48 है, कितना साइज का सैंपल हम उसमें से लें कि सैंपल मीन की वैल्यू 370 380 के बीच में हो, इसकी प्रोबेबिलिटी 95% से ज्यादा हो। मतलब हमें ये फाइंड करना है व्हाट इज द वैल्यू ऑफ n such that probability that 370 less than equal to x bar less than or equal to 380, this probability is at least 95%. तो हम इसको कैसे सॉल्व करेंगे? हम इस प्रोबेबिलिटी जो हमें कैलकुलेट करनी है ये इनइक्वालिटी हमें सॉल्व करनी है और n की वैल्यू फाइंड करनी है। तो सबसे पहले तो हम इसको स्टैंडर्ड नॉर्मल डिस्ट्रीब्यूशन में कन्वर्ट कर देंगे बाय सब्ट्रैक्टिंग मीन फ्रॉम बोथ साइड। थ्री 80 है ये। And then we divide by standard deviation of the sampling distribution of sample means, which is sigma by root n. Now we substitute the value of sigma, which is equal to 48 in the question. Five 48. Now this is 0.95 here. We already know that the probability that z lies between minus 1.96 and plus 1.96, its value is 0.95. याद है आपको? Now comparing equation number 1 with equation number 2. Comparing equation 1 and 2, we get हमें ये probability 0.95 से ज़्यादा चाहिए, तो ये वैल्यू 1.96 से बड़ी होनी चाहिए। तो 5/48 root n should be greater than or equal to 1.96. So after solving this, we get n is equal to 355. Sample size must be at least 355 to be ensure 95% that the sample mean will falls between 370 and 380. Okay. So rest of the lecture will be continued in lecture number 28. So don't forget to subscribe my channel to get the notification about new videos on this subject. Thank you very much.